Hi, this is Adam with Contemporary Woods. Today we're at the Power Fed router table. We do have a couple procedures on how to set this up. I want to go over a few other things that aren't documented in the procedure so you can watch this and know how to set up the rest for success. First off, let's talk about a few improvements we've made recently. That is labeling what's in the drawers. So now we know what's behind the drawers. Everything's labeled. We also did this improvement, and Chris on our team helped take this from here to this drawer. This is what we just did today. And this is how to set up the router. We probably should label the front of the drawer actually. This is how to set up the router bit, how to put the router lift in the right height, and configure the router throat plate. All that is in this drawer. It's also in the order that you need it, basically. This drawer has the tools necessary to change the speed on the Power Fed router. So here's your chart. All of the different small power feeders have a chart here. You rearrange the gears or you swap out gears and you get the different feet per minute. What we need to do next, and we haven't done yet, is create a chart that says, hey, for a 1/4 inch roundover, use this feed. For 3/4 roundover, use this feed rate. The larger the bit, the slower you want to go. Once we have this gear swapped out here, then we can start making test cuts. I'm going to flip you around to another great improvement we've made. Over here is test materials. This just got done this week. We have a bin of different sizes. It's for the Power Fed rip saw and the planer, so you can run a test to make sure you're calibrating before you run the whole batch. So back to over here, we took some material out of that test bin and we ran a test, and let me show you the results. If you can see here, there's a big chip out there. There is a big chip right here. I don't know if that catches in the camera. Because what we were doing, and here's even more big chip out. What we were doing is running at the full router bit cut. And that did not produce us the quality at the source that we want to pass on to our next internal client, which is sanding and finish preparation. So what we did is made sure the power feeder was on the slowest setting possible. We've also slowed the router bit down a little bit because it's a little bit bigger cut. We want to make sure there's plenty of torque and it doesn't slow down. And then we've made a quick improvement for the router table, and that's this quick stop block. So if you have it at its final pass, now we have it set up where we can make 2 passes. I can move the the fence. I can put a nominal block in here. I can set it. And now I'll show you how this works. So we're going to put our safety equipment on, make sure the dust collector is powered up to collect the chips. Always turn on the router first, then the power feeder. Orientate my test piece. That was a partial depth cut. We're going to do a 2-pass cut. So I'm going to take my fence loose. I'm going to put it back to my stop. I'm going to take my board. And now we can compare the results, the differences. Look along this leading edge here of where the cut stops. You can see before it was all chipped out, and after it's not. Now I know this is oak and this is birch. The project's in birch. We did our test piece on another species because we knew birch was even going to be more chippy than oak typically in our shop. So this is the results. To recap what we've done, we've tried to standardize how the machine is set up. We've set advanced stops up that are easy to replicate. We've set the standard on how to set up the power feeder on a slower route, slower speed, and set up the router, and have the multi-position fence for 2-pass cut, which gives us great results, yet again passing on quality at the source, not at the end.